Yeah, hello everybody. So today actually we are going to learn about sequence modeling. Okay. Up to the last class, you got details about this transfer learning and some models related to the transfer learning. Now that will again means need it for some practicals, but at the same times we should know about this sequence modeling. So without any delay, let me share the screen for you. I hope you can see my screen. तो sequence modeling क्या है actually? So you can go through the definition. Sequence modeling is a task or problem domain that involves predicting or modeling patterns in a sequential data. तो यहाँ जिसमें हम ज़्यादा फोकस कर रहे हैं वो है क्या? आपका sequential data, right? सीक्वेंशियल वन आफ्टर अनदर। ओके, सीक्वेंस का मतलब तो आप लोगों को पता होगा कि सीक्वेंस का मतलब होता है वन आफ्टर अनदर। Okay, different kinds of sequential data can be modeled, interpreted, and predicted by a sequence modeling tool, including your text data, audio, video. Okay, now what is the advantage? Advantage of sequence modeling are like it captures temporal dependencies in data, then it can handle variable length input, right? Then it is widely used in NLP. Then it is essential in. Just 1 second. Again, I need to share the screen. Okay. I hope you can see it. So हम क्या बोल रहे थे? Sequential that modeling का advantages क्या क्या है? So it captures temporal dependencies. It can handle variable length input, right? And then it is advantageous in serial time series prediction tasks and widely used in NLP, essential in speech and audio processing, enables sequential data decision making in various domains. So different types of sequence models are like जो हम यहाँ पे डील कर रहे हैं, first RNN, autoencoders, and seq to seq or sequence to sequence. Okay. To achieve memory-based learning, a unique AI algorithm known as recurrent neural network is used. RNN माने होइसे recurrent neural network. समझ में आ रहा है? तो यहाँ जो memory aspect है, the memory aspect in RNN refers to their ability. ये important point है, you can note it down. The memory aspect in RNN refers to their ability to use information from previous steps and or in the sequence to inform their current output. This is particularly useful in the applications where the context is essential. तो RNN का जो मेमोरी एस्पेक्ट है उसका मतलब क्या है? उसका मतलब ये है जो प्रीवियस से इसका इंफॉर्मेशन है वो यूज कर सकते हैं। ओके, प्रीवियस टेस्ट का इंफॉर्मेशन यूज कर सकते हैं इन द सीक्वेंस टू इन्फॉर्म देयर करंट आउटपुट। और ये कब यूजफुल होता है? जब हमें कॉन्टेक्स्ट इंपॉर्टेंट होता है हमारे लिए, वेयर द कॉन्टेक्स्ट इज एसेंशियल। ओके, अब इसमें देखो, द फॉलोइंग इमेज शोज द वर्किंग ऑफ ए सीक्वेंस मॉडलिंग। ठीक है, ये आ रहा है एक्स आई, आर एन एन, वाई आई। आप इसको एक्स वन, आप ये देख सकते हो x2, x1 टू y1 गया आपका। अब ये y1 जो है इसको हम नेक्स्ट में x2 rn y2 यहाँ पे यूज कर रहे हैं प्रीवियस स्टेप्स का जो आपका इंफॉर्मेशन है, हम ये करंट स्टेप में यूज कर रहे हैं। सिमिलरली y2 गया y3 डॉट 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 अप टू xi टू yi। तो ये जो आपको दिखाई दे रहा है ये इंफॉर्मेशन, प्रीवियस टेस्ट का इंफॉर्मेशन हम RNN में यूज करते हैं। It is used to generate a sequence of values by analyzing a series of input values. So the input values may be time series data where variables vary over time. It analyzes the recurring input values and sees them as discrete inputs for different problems or cases. Real-world applications like projective sequence modeling can be used in NLP to process text into valuable insights. जैसे कि an email spam classifier enhances user experience by identifying and filtering out the unwanted or harmful emails, keeping inbox organized and secure. Or you can take another use case like a computer program that takes an audio file as input. Audio file को input से लिया है, हमारा input क्या है, तो फिर एक audio file. Then it recognizes which possible genres, and different genres are there for the music, right? And it, based on that, it can suggest a sequence of musical notes to complete the song. ये हो गया audio data के केस में. Right. So this could aid musical composition as several musicians face problem in decrypting the symbols early on their careers. Okay, अब मैं फिर से RNN में आता हूँ. RNN मतलब आपका recurrent neural network. First, feed-forward neural networks in RNN. RNN were introduced after feed-forward neural network, that is FNN, to address the limitation of processing sequential data. क्योंकि मेमोरी का बहुत इशू था. सीक्वेंशियल डेटा में मेमोरी बहुत जरूरी है, जो कि जो हुई डिसएडवांटेज था, उसी डिसएडवांटेज को हटाने के लिए हमने RNN को इंट्रोड्यूस किया. You can see here input layers, hidden layers, output layer, outputs. That is a sequential model, right? Okay. Now, consider the following image here and create a computer program that suggests a sport to be played based on the time and weather. Okay. Export उस टाइम में प्ले करना सही है कि नहीं, वेदर और टाइम के ऊपर बेस करके, राइट? टाइम डेटा इट इज कमिंग, वेदर डेटा इज आल्सो कमिंग, देन बेस्ड ऑन दैट इट इज बीइंग डिसाइडेड. इससे क्या समझ में आपको आया कि इट फॉलोज अ पर्टिकुलर पैटर्न एंड मेक्स एप्रोप्रिएट डिसीजन. Now, it might suggest football in the evening in clear weather or badminton when there is no wind. Now, FNN would suggest the same sport for similar weather condition every day, but RNN would remember the user's choice from the previous day and suggest something different in the next day. अगर completely आपका जो ये feed forward neural network होगा, वो जो output मिल रहा है उसी same output, same suggestion वो देगा. FNN would suggest the same spot for similar weather condition every day. But RNN क्या करेगा, यूजर का जो चॉइस रहा कि ऐसा मौसम रहा था, वो खेलना सही या नहीं सही, ये चॉइस को वो रिमेम्बर कर सकते हैं मेमोरी एलिमेंट के कारण, एंड वो it can suggest something different in the next day, right? So you can see the definition here. RNN, that is recurrent neural network, is a state-of-the-art algorithm used by Apple Siri and Google's voice search. So Apple का Siri, you all know, and Google's का voice search, ये RNN use करता है. It is the first algorithm that remembers its input owing to its internal memory, and the ability to add recent past to the present allows it to make a precise predictions. Got it? Now, ये तो definition समझ में आ गया. So it is ideal for ML problem that involves sequential data like natural language processing and time series forecasting. Sequential data कि इसके बाद ये, right? Sequence based. So RNNs are mainly used for sequence classification, sequence leveling. Like sequence classification में आप देख सकते हो sentiment classification, video classification, and sequence leveling में आप देख सकते हो part of the speech tagging, named entity recognition. Okay. Different types of RNNs are like one-to-one, one-to-many, one-to-many, right? ये figures को ध्यान से देखो. One-to-one, one to many, many to one, many to many. Now let's come to one-to-one. One-to-one architecture form the basis of feed-forward neural network, an architecture that is used to classify the image of a musical symbol, suppose, right? So one-to-one है. So activation values are not needed as this is a straightforward scenario of a single input and single output. तो यहाँ पे activation values की जरूरत नहीं है, एक input का एक output. Then one to many. यहाँ पे क्या है? A single input drives the entire network. A single input के लिए आपको अलग अलग different output आपको मिल सकता है. So generating a sequence of musical notes based on the first note or the genre of the music given as input. एक नोट दिया या तो आपका जेनरेट दिया, उससे आपको पूरा सीक्वेंस ऑफ म्यूजिक नोट को जेनरेट करना है. तो ये किस में आ जाएगा? वन टू मैनी. So once the input is given, the network produces a series of outputs, one for each time step. Next, many to one. So sequence of multiple inputs given to the network, which is instructed to predict a single output. क्या आप लोग मुझे इसका एक एग्जांपल दे सकते हो? You can easily give. Like the tasks of classifying genre of music by giving song as an input. एक song दे दिया, एक गाना दे दिया, तो उससे आप जेनर को पता लगा रहे हैं. उल्टा हो रहा है, पहले एक जेनर दिया था, एक नोट दिया था, उससे पूरा सीक्वेंस को, म्यूजिकल नोट को जनरेट करना था. और यहाँ पे अभी हम क्या कर रहे हैं? पूरा म्यूजिक दे रहे हैं, उससे आपको जेनर को क्लासिफाई करना है. तो वो आ जाएगा आपका मेनी टू वन. देन मेनी टू मैनी. मेनी टू मैनी में क्या हो रहा है आपका? Multiple inputs and multiple outputs. So a sequence of multiple inputs is fed to the network to predict a sequence of outputs that may or may not be of the same length. Like an application for generating a string of musical symbols by giving musical notes or shorts as input. तो हम एक क्या जनरेट कर, इस वन स्ट्रिंग ऑफ म्यूजिकल सिंबल्स क्या करके म्यूजिकल नोट्स और शॉर्ट्स को इनपुट दे रहे हैं हम. तो such neural networks have two components, the encoder and the decoder. many to many में आपका encoder and decoder दोनों ही है. तो इसका एडवांटेज क्या है? व्हाट आर द एडवांटेजेस ऑफ रिकरेंट न्यूरल नेटवर्क? So, like weights can be shared across time steps. Model size is not affected by input size. Model can process inputs of any length, and model is designed to remember each piece of information and is helpful in any time series predictor. Clear? नाउ डिसएडवांटेज क्या है? डिसएडवांटेज ये है कि सम डिफिकल्ट, फर्स्ट ऑफ ऑल the computation is slow due to the recurrent nature, then difficulty in training RNN model and issues with exploding and vanishing gradient. सबसे important तो vanishing gradient एक problem है. ठीक है. Now architecture and working of RNN. Architecture को देखो आप. ठीक है. तो RNN architecture is designed to process the sequential data by capturing temporal dependencies and retaining the memory of previous inputs. Right? ये input layer है आपका. This is the input layer. Right? As it is hidden layers and output layer. Now recurrent neural network में आपको जो input मिल रहा है, ठीक है, ये input को हम recurrently एक दूसरे से कनेक्ट करके अल्टीमेटली आउटपुट मिल रहा है. ठीक है. तो हम प्रीवियस स्टेट्स का इनपुट इंफॉर्मेशन को हम याद रख रहे हैं. राइट. सो इट कंसिस्ट ऑफ थ्री मेन कंपोनेंट. तीन कंपोनेंट्स है आरएनएन में. एक तो इनपुट लेयर, हिडन लेयर विथ रिकरेंट कनेक्शंस एंड आउटपुट लेयर. ये इनपुट लेयर, हिडन लेयर, बट इसमें रिकरेंट कनेक्शन दिया है. राइट. ताकि लास्ट इंफॉर्मेशन इसको मिले. And ultimately output layer. So X is input layer, S is the hidden layer, and Y is the output layer. Parameters, क्या parameters हैं? A, B, C. A, B, C are utilized to enhance the model's output. The output at each time step is feedback into the network to improve the subsequent output. यही इसका concept है. One input layer, one hidden layer with recurrent connection, one output layer. So generally we can describe as a stepwise manner like this: initialization, input processing, hidden states update, output calculation, and then training. ये पार्ट से आप देख सकते हो, ठीक है, हाउ इट डिफर्स फ्रॉम द अदर नेटवर्क्स. Initialization begins with initialization where the hidden state is set to a vector of zeros or random values, and then RNN is defined including the number of hidden units and activation functions. So, ये डायग्राम में x आपका क्या है, इनपुट स्टेट है, x input state है, s is the hidden state, o is the output, right? And network weights are like u, v, and w. U, v, w. यहाँ पे देख रहे हैं v, u, w. ठीक है, ये था आपका इनिशियलाइजेशन फेज. Then input processing. During input processing, the input sequence is processed one element at a time. इस फिगर में आप ध्यान से देखो, in this figure, xi is the input, मतलब xt, sorry, and this st is the hidden state at time t, and st minus 1 is the hidden state from the previous step t minus 1. समझ में आ रहा है, previous step. Okay, now the current input जो है is combined with the previous hidden state जो कि आपका st minus 1 to capture the contacts and the dependencies, and the activation of the hidden layer is computed based on this combined input, not only single input. previous state का hidden state जो मतलब previous time state था उसका भी ये context लेके decide किया जा रहा है. तो current input is combined with the previous hidden state to capture the context and dependencies, and accordingly the activation of hidden layer is computed based on the combined input. Then input processing. Use the following equation to combine the current input with the previous hidden sets. WXH into XT plus WHH into HT minus 1 plus BH. ये W जो XS है, ये क्या है आपका? It represents the weight matrix for input to hidden connections, input to hidden connection. WHS represents weight matrix for the hidden to hidden connections, and XT represents the current state input, and BH is the bias term for the hidden layer. H दिखाई दे रहा है आपको. So, and AT is the combined input to the activation function in the RNN cell that determines the new hidden state ST. Okay, let me clear the screen for you. So hidden state update, the hidden state is then updated using the computed activation of the hidden layer, allowing information to flow across the different time steps, right? Now we compute the activation of the hidden input using a hyperbolic tangent activation function, which is tan h of WHS into HT minus 1 plus WXS into XT plus BH plus BX. Very simple equation. Clearly you can note this is a tan h. So HT क्या था यहाँ पे? Hidden state. WSS is the weight matrix that determines the influence of the input XT on the current hidden state ST, right? And WXS means it weight matrix that determines the influence of the input XT on the current hidden state ST. ठीक है, SS hidden के लिए है और XS current के लिए. ठीक है, weight matrix that determines the influence of the input XT on the current hidden state. तो ये आपका हो गया एक्टिवेशन फंक्शन. Then output is very simply you can calculate with yt is equal to why into ht plus by. So out of the network, output of the network is calculated based on the updated hidden state and any necessary transformation or activation functions applied to obtain the desired output format. So this is the equation yt is equal to why into ht plus by, where why denote the output layer, which by is the bias term for the output layer, and yt is the output. Okay, so during training, the RNN calculates the loss between the predicted output and the target output, and the weights and biases of RNN are updated using peak propagation through time, BPTT, and an optimization algorithm. So process helps RNN learn how to make more accurate prediction and improve its performance. तो ये सफिशियंट है आज का कॉन्सेप्चुअल पार्ट के लिए. हम LSTM को डिस्कस करेंगे बाद में। जो अभी मैं RNN के बारे में बताया, यू गो थ्रू इट, विल डू वन प्रैक्टिकल आफ्टर दैट, बट फर्स्ट कंप्लीट दिस लेसन। थैंक यू।